So, hello class! May muling nagbabalik para sa bagong lecture video series. So, for this lecture video series, ang pag-uusapan natin is the part 1 of Module 4, which is Differential Amplifier. Okay, so bakit ba natin kailangan aralin yung Differential Amplifier? So, actually, Differential Amplifier is used dun sa operational amplifier po. If you will check the schematic circuit po ng internal circuit ng isang operational amplifier, makikita nyo meron tayong first stage na differential amplifier po. Okay, so kaya kailangan muna nating i-discuss si differential amplifier bago tayo mag-proceed sa operational amplifier circuits. Pero bago tayo mag-differential amplifier, kailangan muna natin malaman kung ano bang pinagkaiba ng differential and single-ended signals. Dahil we have two types of signals kasi. We have differential and single-ended. So what's the difference between the two? So let's start. So let's consider the arrangement of the voltage sources shown here in the PowerPoint. You can observe that there are two ways in doing voltage readings, di ba? First is reading the voltage of a node, let's say in the node 1, with respect to ground. Meron tayong voltage na ma-measure dyan. The same po sa node 2. We can measure the voltage at node 2 with respect to ground. So yun po yung reading the voltage of a node with respect to ground. And another way naman is we can read the voltage between nodes 1 and 2. So again, one way of reading is reading the node with respect to ground. And the other naman, reading the voltage in between the two nodes. So wala po tayong kino-consider na ground kapag reading between two nodes tayo. Okay? So yung reading from a certain node with respect to ground is called the single-ended signal. So for this example, it is the voltage at node 1 with respect to ground. And the voltage at node 2 with respect to ground is also a single-ended signal as well. So yung isang type ng reading naman is called the differential signal. Okay? Kung saan nagme-measure tayo ng voltage between two nodes. Okay? Wala tayong pakialam kung nasaan ba yung ground ngayon. Ang mahalaga sa atin ngayon, nagme-measure tayo ng voltage between two nodes. Okay? Sir, what is the VCM over here? And what is VV? Ba't ganyan yung arrangement? Okay, so pag-uusapan natin mamaya si VX. Dito muna tayo kay VCM. VCM is called the common mode voltage. So, bakit siya tinawag na common mode voltage? Because if we will try reading voltage at node 1, saka sa node 2, makikita nyo, both signals will have the common mode voltage. So, that's the reason why it is called the common mode voltage. It is common on both V1 and V2. So, si VCM lumalabas lang po yan kapag nagre-read tayo ng single-ended signals. Kapag nagre-read tayo ng differential signals, for example, VD, nawawala po yung VCM. So, typical VCM po sa amplifier circuits ay some DC voltage po to bias our amplifiers po. And in other cases naman, in signal reading naman, it is called the common mode noise. Kapag AC yan, it is the common mode noise. Kapag DC yan, it is the biasing voltage natin sa ating amplifier. So, the question is, can we convert two single-ended signals into a differential signal? So, kapag meron tayong V1 na measurement and V2, makukuha kaya natin yung differential signal? Okay, of course, makukuha natin yan dahil first of all, VD or the differential voltage is the voltage between node 1 and node 2. So kung natatandaan natin, for example, we have reading na VAB. So it is equivalent to VA minus VB, di ba? And what is this VA and VB? So these are the measurement with respect to ground. Okay? So therefore, VD is equivalent to V1, 2, di ba? Because we are measuring the voltage between nodes 1 and 2. So, ibig sabihin, we can represent it as V1 minus V2. And ngayon, malalaman natin kung ano ang value actually ng Vx natin. Okay? So, gagawin natin yan by substituting the voltage reading at node 1 and node 2 dito sa V1 and V2 natin. So, what will be the reading at the node 1 or V1? So, V1 is actually the voltage from this node to the ground, which is, madadaan natin yung Vx and ang nadaanan natin is positive, so positive si Vx. And madadaanan natin si VCM and nadaanan natin una is positive, so positive din po si VCM. So therefore, V1 is Vx plus VCM. And the voltage reading at node 2 or V2 is actually negative Vx dahil mula sa node 2 papuntang ground, ang una nating nadaanan sa Vx is the negative terminal. Kaya siya negative dito. Tapos pag diniretso natin, madadaan natin yung positive terminal ng VCM, kaya positive ulit siya. So substituting this V1 and V2 sa ating VD, ang lalabas na Vx is actually VD over 2. Okay, so tandaan, Vx is actually VD over 2. Okay, so sir, paano naman yung VCM? Kasi yung alam natin dyan si V1 and si V2. Is there a way to compute or to find VCM? Okay, so madali lang yan. Since meron na tayong reading voltages ng 1 and 2, pwede natin gawin is we can add equation 1 and equation 2. Diba? So, i-add ko lang po yan. So, ang lalabas dyan is V1 plus V2 is equal to Vx minus Vx, which is 0, plus VCM plus VCM. And ang mangyayari dyan is V1 plus V2 is equal to VCM times 2. So, therefore, VCM is V1 plus V2 all over 2, or the average of V1 and V2. So, kapag sinubstitute natin yun sa ating formula, makikita natin that VCM nga na may matitira kapag kinuha natin yung average ng V1 and V2. So, bottom line is kapag alam natin yung voltages at nodes 1 and 2, malalaman din natin kung ano yung differential voltage and the common mode voltage. So, for example na lang po ito. So, meron tayong voltage at node 1 or sa VV1 and voltage at node 2 or VV2. So, to get the differential voltage, we'll just subtract VV2 from VV1 or VV1 minus VV2. So, ito po yun, yung color red. So, ito po yung nakuha nating differential signal using subtraction. And ito naman, this is the differential signal measurement itself. So, ang mapapansin natin, yung ginamitan natin ng equation and yung measurement is the same. Di ba? So, it has 0 DC plus 1 volt peak amplitude of a sine wave. Dito naman sa right side, again, we have measurements for VV1 or the voltage at the node 1 and the voltage at the node 2 or VV2. So, using yung equation kanina, which is the average of V1 and V2, makuha natin yung computed na common mode voltage. And the measured common mode voltage is this one. And mapapansin nyo, yung computed common mode voltage and the measured common mode voltage ay the same. So, this proves na tama po yung ating equations kanina. So, how about kabaliktaran naman? What if we have the differential voltage and the common mode voltage? Paano natin nako-convert yon to single-ended signals? So, edi gagawin natin, meron tayo kaninang readings, di ba? So, nakita natin that V1 is equal to Vx plus VCM. And V2 is negative Vx plus VCM. Tapos, we found out that Vx is actually equal to Vd over 2. So, ang gagawin lang is isa-substitute natin yung Vd over 2 dun sa mga Vx natin. So, therefore, V1 will be Vd over 2 plus VCM and V2 is negative Vd over 2 plus VCM. So, ito po yung example. We have a measured differential voltage between nodes 1 and 2 and we have the common mode voltage. So, by taking the half of the differential voltage plus the common mode voltage, nakita natin na siya ay equal to the voltage at node 1. So, in the right side naman, we have again differential voltage between nodes 1 and 2 and the common mode voltage. By using the formula or negative ng Vd over 2 plus VCM, napalabas natin yung voltage at the node 2. So, sir, bakit pa natin pinag-aralan yan? Okay, so kasi yung conversion na yan, mapapadali niya ang ating analysis. Okay? Dahil usually for a differential amplifier system, it amplifies the difference between two nodes. Ibig sabihin, our input should be differential. Okay? Pero medyo mahirap kasi ang analysis kapag ganon. Bakit? Kasi ang lagi nating analysis sa amplifiers is voltages with respect to ground or single-ended signals. So ngayon, we need to find a way to convert this differential signal into a single-ended one. So every time na makakita tayo ng ganito or ina-amplify yung voltage difference between nodes, gagawin natin is ito-drawing lang natin yung arrangement kanina. Diba? Ito yung arrangement kanina. This is Vx, diba? And next step is yung VCM na isa, gagawin nating dalawa. Okay? And i-connect natin sila in parallel. As we can observe over here, these two VCMs are connected in parallel. So, bakit natin ginawa yan? Kasi, gusto natin talagang mapaghiwalay yung mga voltages sa ating node 1 and sa ating node 2. Dahil kapag ginawa mo yan, yung current dito sa wire na yan will be 0 or walang kuryente dyan. Kapag walang kuryente dyan, pwede natin ngayong tanggalin yan. Diba? So, pag tinanggal ko yan, ang mangyayari is ganito. So, pwede na natin ngayon i-analyze ang ating amplifier using single-ended signals. Pero yung single-ended signal natin na V1 is composed of VD and VCM. Same din po sa single-ended signal sa node number 2. So actually, in the next episode, makikita natin kung paano ba kino-convert yung differential to single-ended para mas mapadali ang ating circuit analysis. So, sa ngayon, hanggang dito na lang muna. For the next episode, tutungo na tayo sa differential pair. Ano ba yung differential pair? Saan ba ginagamit yun? And etc. Okay, so I will see you in the next one. Bye!